Objectives for this lesson are as follows. We're going to describe what is meant by the term periodic trend. Then we're going to understand and explain the period and group trends of different properties among elements. We're going to look at 4 in particular. And finally, we're going to describe the effect on an atom when it becomes an ionic radius. Key terms for the lesson are periodic table, period, group, atomic radius, ionic radius, electronegativity, and ionization energy. And those bottom 4 are the 4 different sections we're going to look at in this lesson. First of all, then, what is a periodic trend? It's important we understand this term before we discuss the 4 different periodic trends we are looking at. So these periodic trends are patterns that emerge across periods or down groups. And we should know that periods are the horizontal rows and the groups are the vertical columns. And this is because the properties of elements tend to change in predictable ways. So elements that are in the same group have very similar properties that change very slightly, okay? But we can predict how they will change. There are certain exceptions to these trends. We are not going to discuss the exceptions in detail this year, but you will do in future years. So we're going to start with something called the atomic radius. Now, straight away, when we talk about atoms, you should be thinking about how small they are. So this radius is very difficult to measure. And how we do it for metals is we define it as half the distance between adjacent nuclei in a crystal. Okay, so it's half the distance between 2 adjacent nuclei in a crystal. For a non-metal, it's defined as half the distance between 2 nuclei of identical atoms that are chemically bonded together. And I've got an example here. So this is the atomic radius of hydrogen, H2. Now please be aware that it's only half of the distance that's shown on that line. So the atomic radius would actually be this here, okay? It's half of the distance between the nuclei of identical atoms. So we've got atomic radius of 1 here, and we've got another one just here. Atomic radii trends. So generally, as we move across the period, the atomic radii will decrease. It becomes smaller. Now, what you've got to remember is as we go across the period, all of the valence electrons are located in the same principal energy level. So they're all in the same principal energy level. However, as you move across the period, the number of protons in that nucleus is increasing. So the nuclear charge is more positive, and that attracts these valence electrons more strongly, and it causes the atomic radii to get smaller because of this stronger attraction. Now, as you move down the group, it's the opposite. So the atomic radii will increase, and this is because those valence electrons are getting further from the nucleus because we're increasing the principal energy levels that are present. Okay, and what this means is the electrons are more shielded from the nucleus, so they're not as strongly attracted, and therefore the atomic radii will increase. Now the graphic here just illustrates that. So as we move down the group, we increase the size of the radius, and as you move across the period from left to right, the size of the atomic radius will decrease. If I take francium, for example, it's at the bottom of group 1, okay, and it's right at the start of its period, so it's going to have a very large atomic radius. Whereas, for example, if I take fluorine is quite near the top of the group, which is right at the top of group 17, and it's quite far along the period, so it's going to have a small atomic radius. Ionic radius then. So this is linked to the atomic radius, but this time we're going to be talking about something called an ion. Now, atoms are able to lose or gain electrons to become ions, and they usually lose or gain their valence electrons. Now, if an atom loses electrons, remember these are negatively charged, so if it loses these negative charges, it becomes more positive, and it actually decreases in size. Now, you've got to think it's losing these valence electrons, which are right on the outside. It means it has an empty orbital and therefore becomes smaller. On the other hand, if an atom gains electrons, it's gaining negative charges, so it becomes a negatively charged ion, and it will actually increase in size. And this is because the gained electrons will fill the remaining orbitals and it causes repulsion. Now, if things repel, they move further apart, and therefore they're going to increase the size of the ion. If we go through ionic radii trends then, it's not quite as simple as saying as you move across the period this happens, and as you move down the group this happens. Okay, so as you move across the period in general from group 1 to 14 the ionic radii will decrease. Now this is because in general as you move from group 1 to 14 they are positive ions and they get smaller and smaller. Now when you reach group 15 it becomes a negative ion, and this negative ion is much larger than the previous positive ion. Okay, so group 15 it increases in size, but as you move across from group 15 over to group 17 it becomes smaller once again. And I've got a diagram here, and hopefully this illustration will help you understand what I've just been talking about. So we've cut out the middle section, but we've got groups 1, 2, 13, 14, 15, 16 and 17. As we go across this period from group 1, 2, 3, 13 and 14, you will see that this ionic radii is getting smaller and smaller. Now when we get to group 15 it becomes a negative ion and it increases in size hugely. Okay, but as you go from group 15 over to group 17 once again it gets smaller and smaller. Okay, so as we go across the period in general it becomes smaller. The positive ions get smaller and smaller and smaller until we hit group 15 where it becomes a negative ion. It increases in size before becoming smaller again. Now if we look at the trend as we go down the group, this is a bit easier to understand, and you'll see as you go down the group the ionic radii will increase in size. This is because again we're increasing the number of principal energy levels, and therefore the electrons are getting further away from the nucleus and it is increasing in size. Thank you for listening to this presentation. There will be a second part to periodic trends that you need to watch.